Hello.
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 Hello. Hello.
Hello.
Welcome to Fourth International Symposium on Multidisciplinary Studies and Innovative Technologies. Due to COVID-19, we are holding our symposium virtually. I hope this epidemic will end as soon as possible. Let's start the session. Mr. Tahir Hassan Abdullah is here. Mrs.
Suparada.
Soparada. Yes. If you are ready, you can start your presentation. Are you ready your presentation?
My cue is on the second.
Yes, but Tahir Hassan Abdullah is not online.
Okay, I'm ready.
Okay.
So can I start?
Okay. You can share your screen.
Okay.
Presentation screen.
Presentation. Okay. Hello everybody. I'm Suparada Themani and Dr. Siladon Silithara. I'm studying master degree from the Cluster of Logistics and Rail Engineering, Faculty of Engineering, Macedonia University. Today I will present the title of the Public Transportation Infrastructure Improvement at Chang in Trat Province, Thailand. The personal car across to Chang Island is growing every day. The proportion of the segment share is approximately 98%. In contrast, the public transport is only 0.4% from year 2018. The critical point is from the transit schedule of the public transportation that vary according to the transit schedule of the ferry services across to the island instead. The ferry service frequencies are every 45 to 60 minutes for off-peak demand and every 25 to 45 minutes for peak season. The fare rate is drawn into the case, though there is already policy fare supported for distance-based fare. It is unavoidable to depend on the load capacity of the public transport in practical. The maximum seat capacity is at 12 seats, plus around 3 to 5 crowded standings if needed. However, the maximum 12-seat capacity is required to full load before dispatching from the public transporter perspective. If not, the passengers need to wait for the next arrival of ferry or even a non-charge until full passengers are loaded. Another option is the passenger need to pay for a shuttle to cover the empty seats by negotiating with the driver to depart without waiting to full load passengers. This means passengers bear for the higher rate, either by turn or by monetary than expected policy. The objective in this work consists of the first one is to find and to analyze the willingness to pay with fare rate from passengers. The second one is to find and to analyze the maximum optimization of the fare from willingness to pay by headway scenario, 15 minutes, 30 minutes, and 60 minutes, and origin destination pairs for short loop, medium loop, and long loop, and to study and analyze transport costs to optimize with fare rate. The willingness to pay estimation for fare structure, Blinder and Hashler and Reuteler suggested that the willingness to pay, or the WTP, is one of the economics way to find the maximum price. Then the price is appropriated and can lead the organization to grow. Wu and Lu and Shan and Wang suggested that if the price was applied inappropriately at the first time, it was not easy to recollect it later to the consumer, since it could lead to the equity perception. And Wobola studied fare-free service at Lane Transit District and claimed that to improve only fare is insufficiency. Then Dandapat and Maitra suggested that the demand level and the route length are affected to the fare model. Asplan and Riddock set policy scenarios for fare only, frequency only, welfare, and Pareto scenario. Their study was based on peak and off-peak period. It is found that fare and frequency as test is affected to the chain of public transport demand. They also claim that the optimal frequency is more important than optimal fares. For the policy headway, CEDAR presented that the policy headway is one of the service standards to improve the efficiency, effectiveness, and productivity in public transport service. Firth and Wilson claimed that the policy headway is one of the uttermost methods in transit frequency setting. Then Lee and Bushik suggested that the frequency and headway are different but closely interrelated each other, and is often misunderstanding to apply. Cortez, Diaz, and Tilashini evaluated the cost components of the public transport to find the optimization of frequency by developing an integrated deadheading short-turning strategy, or IDS. The scheme was tested as short circles to serve in high demand. Then the cost and headway were decreased. The final is Ford and Wilson suggested a new model for frequency setting using an algorithm for nonlinear program. It was claimed that the important factors like policy headway, max load procedure, vehicle yield, and revenue and cost were relatively with frequency setting. The policy headway is effective from low demand and usually set with 60 minutes or 30 minutes. Here is the methodology plan to policy headway scenarios. Figure 1 presents policy headway in 3 scenarios for the research. Headway 15 minutes, 30 minutes, and 60 minutes into 6 origin destination pairs. Origin destination 1 or OD1 from eastbound route, and origin destination 4 or OD4 from westbound route stand for short turning of public transportation service. Origin destination 2 or OD2 from eastbound route, and origin destination 5 or OD5 from westbound route stand for medium loop of public transportation service. And the last coupon pair of origin destination 3 from eastbound route and origin destination 6 from westbound route stand for the longest loop of public transport service in this study. All 6 origin destination pairs were tested in policy headway scenario 15 minutes, 30 minutes, and 60 minutes, and policy are tested altogether. The result and discussion of demographic of respondents, it is received for total 389 complete respondents in 3 policy headway scenario and 6 origin destination to elicit willingness to pay off fare. The result appears that the respondents for approximately 7% into 0 fare or free fare without any other fare select This means that these responders are not willing to pay for the public transport fare at all. And it is approximately 7%. The approximation of 6.94% is from the responders who bring the personal car across to the island. This is one of the reasons that why the personal car have the higher proportion percentage to the island. Figure 2 will present the comparison of the responder who bring and who do not bring personal car across to the island. 71.89% was from the respondents who bring the personal car from this survey. Table 1 demonstrates the willingness to pay result under 3 policy headway scenarios: 15 minutes, 30 minutes, and 60 minutes for 6 origin-destination pairs, or OD1 to OD6, as the representative of short-term, medium-term, and long-term. Table 2 presents the value of public transport expenses. There are two main costs of public transport in this research: capital cost and operation cost. The capital cost is fixed cost for 5 years, according to the vehicle service life. For operation cost, it is focused for only internal costs from operator to conduct transport productivity. This research does not focus on any other externality costs. Figure 3 demonstrates the result of the willingness to pay with fare in 3 policy headway scenarios. The OD1 to OD3 pairs from the eastbound route and the OD4 to OD6 from the westbound route. The straight line figures for the total cost per day from supply of transit service if comply the policy scenarios in this test. The curved line presents the willingness to pay with fare based on scenario as above discussed from the demand of transit service. The black dot mark indicate the current revenue from current fare rate of each OD pair for comparison. The orange dot marks are the maximum willingness to pay with fare. It appears that the public transport costs from the short-term and short headway scenarios, or OD1 and OD4 from headway 15 minutes, are too high to cover demand. It is also appears that the long headway scenarios, or headway 60 minutes, the transport costs are lower than the passengers' willingness to pay for every OD pairs. This means that the policy headway scenario 60 minutes can cover both willingness to pay with optimum fare and transport costs can also be applied in real practice for the transporter. From the diagram result in figure 4, it can be concluded that the longer loop has more return to scale than the shorter loop. This can be evaluated from supply of transit service and comply with Lee and Bullshit and Cedar and Wobola for supply longer service attraction. The passengers still be willing to pay at transit service to depart every 60 minutes as long as schedule is reliable or on-time schedule in this study. The interesting is the shortest policy headway scenarios at 15 minutes as test appear that passengers are willing to pay, but not significant difference from other scenarios at 30 minutes or 60 minutes from every OD pair. That means the passengers are still willing to pay at the maximum fare rate until headway 60 minutes. For the OD pairs, the straight line, which means cost from headway scenarios, are lower than the curved line, which means passenger willingness to pay. It is suggested to adjust fare to meet the passenger willingness to pay. Furthermore, the policy headway of frequency is needed to improve accordingly. The limitation of this study are not include the externality costs, such as the pollution or environmental costs, physical condition of the road, user costs, or costs from other human transit options, or other costs like permission fee for public transportation or for the public driver, traffic volume data, road safety, or even black spot analysis. This is because the hillside topography of the Iceland. The kind of vehicles of public transportation here has already categorized and summarized in final to gain the average cost to analysis in this study. The future suggestions are to examine to include the above discussed costs or expand them in categorized. The pedestrian study is also suggested to attack them to increase the passenger demand for public transport, as well as the safety or cost from congestion of the personal cars in the Iceland. Thank you for listening. Any question?
Thank you for your presentation. Dear participant, do you have any question about this article? Okay, no question. Thank you again. I wish you continued success in your career. Hope to see you.
Okay. Thank you.
Thank you. Let's the other Mr. Stefan Giovanno, are you ready for your presentation?
Yes, hi.
Okay.
Can you hear me clearly?
Yes.
Just a second.
Please, you have 10 minutes at most.
Yeah. Okay. Sorry. Can you see the presentation clearly?
Yes.
Okay.
Yes.
So, hi, my name is Stefan Jovanov. Today I will be your presenter. I will present a paper named a GIS-based mapping of mountain peaks, waterfalls, and mountain lodges in North Macedonia. I worked on this paper together with my colleague Andrea Naumovski. We come from the Cyril and Methodius University in Skopje, to be more exact, from the Faculty of Computer Science and Engineering. Our agenda for today is the introduction, where we will give some introductory points on what our main objectives were, the data acquisition, which models we used for our paper, the visualization of the data, where we'll see what we did in ArcMap to visualize the data on a map, and the data analysis, where we can see some histograms and some statistics about the data. We will see the result map, and finally we will conclude the paper. First of all, I would like to start off that the World Health Organization recommends that an average person should have 8,000 steps per day. So the best way to do this is most probably hiking. So basically hiking, we all know that hiking is an eco-friendly tourism, and it can show a lot of we can visit a lot of places by hiking. During these hard times, we have the opportunity to hike in our home countries and explore more and more. So basically what we did and what our main objectives were, to use the hikers or even the average person to visit some waterfalls and some mountain peaks by viewing by visiting the closest mountain lodge. Next up, we will see the data acquisition. The models that we used were the mountain peaks, the mountain lodges, and the waterfalls. So basically the mountain, the name, longitude and latitude, also the elevation. Furthermore, the mountain lodges had the name and the longitude and latitude. And lastly, the waterfalls had their name, longitude, latitude, and their height. So we used these three tables to map out everything. We had around 60 mountain peaks, around 10 mountain lodges, and around 15 waterfalls. The sources that we used are Google Maps, Wikipedia, and other journals. So basically, we use Google Maps to find the longitude and latitude for each and every one of them. We use Wikipedia to find the mountain peaks and their elevations. And lastly, we use the other sources to find the heights of the waterfalls. There were no missing values, so basically we didn't have any process of data pre-processing. Next up, we'll see the visualization. We used mostly we played around with the symbology in ArcMap. So firstly, we changed the basic diamond shape into something else. For the mountain peaks, we used the symbology graduated colors. So we divided the mountain peaks into 5 classes. For example, most of the classes were on a 500-meter range. Basically, what we did was we divided the mountain peaks in range from, for example, from 1,000 to 1,500 meters range, and another class was from 1,500 meters to 2,000 meters range. Furthermore, we even differentiated the sizes of the symbol itself by using the expression builder. So we divided the elevation with a number to get more diversity in the size, but we still divided it with a bigger number that we maintained the mountain peaks as smaller symbols on the map. Furthermore, the mountain lodges, for the mountain lodges, we just changed the icon. And for the waterfalls, we used the stacked symbology, which gave us an overview where we used the height as the main field. And this gave us an overview on the map to see how high the waterfalls were. Next up, we'll see the data analysis that we did. We used the spatial joins in ArcMap to get tables for the proximity lines, and furthermore, we used the Arc toolbox to draw out these proximity lines. What we did was we joined the mountain lodges with the mountain peaks, and we joined the mountain lodges with the waterfalls. Basically, what we got was tables where we contained the longitude and latitude both for the waterfalls and the mountain lodges, and for the mountain peaks and the mountain lodges. Furthermore, we will see some histograms, and we'll see some statistics. By drawing these histograms, we can see that on the left side, we have the waterfalls. You can see from these histograms that the waterfall between 20 and 30 meters. And on the right, we have the same histogram just for the elevation of
Mr. Stevan, Joano, please turn off your video and continue your presentation.
I'm sorry?
Could you turn off the video?
Okay.
Leave video, okay.
Just a second.
Okay, please continue your presentation.
Can you see the presentation clearly?
Yes, yes, yes.
Okay.
Because of internet speed.
I'm sorry?
Okay. Because of internet speed.
Oh, okay, okay. So basically on the right side, we have the mountain peaks, and we can see that most of the mountain peaks, or To be more exact, 7 of the mountain peaks are between 1800 and 1900. And we can also see that we have something that looks like a normal distribution for the mountain peaks. Furthermore, we have 2 box plots, which give us an overview to see if we have outliers and extreme values. For the mountain peaks, we can see on the right that we don't have any extreme values. And for the waterfalls, we can see on the left that we have 1 outlier and 1 extreme value. These are the statistics that we had. We calculated the mean, the standard deviation, minimum, maximum, and the interquartile range together with the median for the waterfalls, for the mountain peaks, and we have a third column, the distance for the waterfalls and the peaks, but from the mountain lodges. So we calculated these using a dedicated calculator for airline between the mountain lodges and the other models. We can see the statistics here. I would let you, if you're interested, view them now or maybe even further in the presentation. And finally, we will take a look at the result map. We can see here that on the result map, we have the diversity between the mountain peaks. We can see the proximity lines that we drew, and we can see the waterfalls. And we also labeled each and every one of them. To conclude this paper, we had some intriguing findings. For example, we saw that the highest mountain peak was located near the highest waterfall. And furthermore, we hope that we helped hikers and even average people to plan their trips using our findings. And I would like to say thank you to the organizing committee of this conference for giving us the opportunity to present this paper. Thank you for your attention.
Thank you very much for your presentation. The participants, do you have any question about this article? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Mr. Mahbubur Rahman, are you ready?
Yeah, I am there. Actually,
okay, please start your presentation.
Okay, thank you. Can you see my screen?
Yes, I see.
So, sorry. So my, I am
MD Mahbubur. You have 10 minutes at most, okay?
Okay. So I'm MD Mahbubur Rahman, and I with two of my co-authors, Hibat Sadiq and Alamin Bishash, are going to present our paper, Bangla document classification using character level deep learning. So paper ID is 139. So that's our outline: basically background, motivation, contributions, literature review, methodology, and result analysis, and control set. Background: actually, Bangla is a very widely used language. About 230 million people around the world are the native speakers, and about 37 million people used this language as a second language. And there are a variety of tasks in Bengali language related to NLP, like categorization, retrieval, and searching. But moreover, methods for task classification or categorization are not sufficient enough. So motivation, most of the tasks are based on like distance measurement, fuzzy interface rules, inverse class frequency method. And in the most recent or previous works, statistical models or different deep learning based models, which are based on word level tokenization, had been used for document classification task. But in this task, we are going to use character level tokenization with without word level token. Sorry, we are going to use character level tokenization. So our contribution, we proposed a document class categorization technique based on deep learning, but our embedding is based on character level tokenization. So we are going to build a more faster and accurate model for categorizing Bangla documents. So there are some works based on document classification on Bangla. So there's a tasker like term frequency or TF IDF. So Onkita et al. Classified Bangla text from defined using linear classification algorithm. Heather et al. Proposed a deep learning based model based on RNN, but their tasks are based on word tokenization. Macedonia et al. Proposed an approach for Bangladesh sports news comments categorization using CNN and multi-layer perception also. So here is our methodology. At first, we collect our documents, and after that, we tokenize each document by characters. And after tokenization, we convert each token into a character ID actually. So after getting that character ID, we convert each character ID to a law space dimension, like 3-dimensional embedding matrix. After that, we send the embedding matrix to a CNN or LSTM block. Finally, a fully connected layer is added after the CNN and LSTM block with a softmax layer to process the output actually. So here are CNN architecture. Actually, CNN or convolution neural network consists of 3 layers actually: convolution, polling, or fully connected layer. So here you can see the architecture of our CNN method. And a long short-term memory cell is a special type of RNN consisting of several kinds of gates. Actually, you can see the here 4 kinds of gates, like input gate, forget gate, and output gate. So in our method, we use 2 LSTM cells sequentially, but after each cell, we added a dropout layer with rate 0.5 to reduce overfitting. So, and a fully connected layer placed after the 2 LSTM layers with a softmax function to process the output. And data acquisition, actually, we collected the data set, 3 different open source data sets. That is called BARD, Prathomalo, and another is open source Bengali corpus, OSBC. So we divided the data by 80-20 ratio. 80% of data are used for training, and 20% data are used for testing purpose. You can see the table for data distribution here. And we trained our model using NVIDIA GeForce 2080 Super GPU. During training, we used 100 epochs with a batch size 8. We used cross-entropy as loss function and Adam as the optimizer with initial rate 0.001 to train the model. So we mainly use 2 different metric for evaluate our results. It's accuracy and F1 score. You can see the formula for the calculation. Actually, for accuracy and F1 score, we need to calculate precision and recall first. So here you can see our evaluated results. Actually, during training, the first picture depicts the accuracy graph, and second picture depicts the loss graph actually. So the normal behavior of accuracy graph is the accuracy will be increased over the epoch or over the time. So you can see the accuracy increased over the time or over the epoch. On the other hand, loss will be decreased over the time. So you can see loss it decreases over the time, but we have also got some fluctuations on loss curve. So I think it's our limitation. During LSTM, we got a smooth graph for both accuracy and loss. You can see the accuracy improves over the epochs, and loss decreases over the epochs. And in both cases, CN and LSTM, you can see that Prothomalo data sets works well. Here is the result for 3 data sets with 2 different models. So you can say Prothomalo data CNN architecture works well in case of bar data set, but for the other data sets, LSTM works well. So this is the discussion and finding of from our results actually. So we can see that Prothomalo dataset works well in both CNN and Prothomalo. And our conclusion, we have implemented a character level approach that categorizes Bangla text documents. So the presented character level encodings achieve the state and art accuracy of the classification task. The overall performance of the LSTM model is satisfactory. So for the 3 different data sets. In future, we want to implement a bidirectional LSTM and BART model for classification, like transformer-based model. We want to introduce some transformer-based models for better accuracy, and also build some more advanced and hybrid models. So that's what the references actually. So thank you for giving me the opportunity to present my work.
Thank you very much for your presentation. Dear participant, do you have any question about this article? Okay, no question. I wish you continued success in your career. Hope to see you, Mahbubur Rahman.
Thank you.
Thank you. The other paper belonged to Sufyan Sabah al-Rifai. Mr. Sufyan Sabah al-Rifai is online. No. The other paper belonged to Sura Abdullah Mernayev el-Dabbak. No. Mr. Saadullah is online.
Yes. Good afternoon.
Mrs.
Yes,
Sorry. Please, if you are ready, you can start your presentation.
Okay. Thank you.
Please, you have 10 minutes at most, okay?
Okay. Thank you. Our document name numerical simulation of filtration process of strongly pelleted oil in a porous media. Consider non-stationary filtration process of highly polluted oil in a non-homogeneous porous medium in a two-dimensional statement. The arbitrariness of the file configuration and the change in reservoir parameters over the area of the reservoir. The uneven location of oil wells in the oil-bearing area and their different variously debit will discrepancy are not limiting factors for the use of numerical simulation in calculation for the development of oil fields. In numerical simulation, consideration of these factors presents significant difficulties for computer calculation of oil fields development. In view of the above factors, unsteady of oil filtration in non-homogeneous porous medium is described by the following differential equation of the parabolic type. This is our formula. when determining the basic indicators for the development of oil fields. Differential equations 1 must be solved at the following initial and boundary conditions. Conditions. For numerical solution of problem 1 to 6 by the finite differential methods, it's convenient to introduce the following dimensionless variables. Below the asterisk in omitted for simplicity, the problem 1 to 6 relative to these dimensionless variables is rewritten as follows. For the numerical solution of dimensional problems, the filtration domains G with external boundary G is covered by a square grid domain with even p's in spatial variable hx equally hy. So now approximating the second equation of the system first with respect to t, the following formula to find the rate of setting of Gale Pettigrew delta in porous media is obtained value, where delta Ig is the value from the previous time layer delta Ig with the initial values for t equally 0 is taken from the initial conditions. This slide we can show our results graphical presentation of calculation results for various configuration of the oil filtration area. And this we can show graphical presentation of calculation results for a square filtration area located in the center of 4 wells with the some flow rates. And so this we can so change in formation proceed with time. This we can show formation permeability with time. Calculation of reservoirs process with account of Gale Pettigrew and reservoir process without taking into account the Gale particles. This we can show calculation results at different viscosite and permeability for the years of oil fields development. Thank you for attention.
Thank you for your presentation. Dear participants, do you have any question for this article? Okay. I wish continued success in your career, Mrs. Naumovsky. Elmira Nazirova, sorry. Mr. Tasir Hassan Abdulmeer is here. Mr. Sufyan Sabah El Rifai is here. Mr. Sura Abdulmeer Nayev is here. That's for a while. Wait for a while.